Hi everyone. We're going to be talking about properties of isosceles triangles today, which is going to be pretty awesome. Okay, we've already kind of talked about equilateral and equiangular triangles, so we're not going to go into much detail on those, but we are going to talk about isosceles triangles, which, looking at this lovely triangle, what do you guys notice about some of the sides? Two of the sides are congruent. So remember, we talked about this when we classified triangles. In an isosceles triangle, at least two of the sides are congruent. And with that comes a lot of properties. In isosceles triangles, we have nifty things that we have to identify about the different parts of an isosceles triangle. So let's go over the parts of an isosceles triangle real quickly. All right, I'm going to skip ahead to here. All right. So in an isosceles triangle, we have special parts that need to get labeled and we need to classify, because in problems they're constantly going to label and talk about these parts of an isosceles triangle. So we need to know what they are. So one of the parts of an isosceles triangle are the base angles. So the base angles are the angles kind of at the bottom of the triangle that are directly across from the sides that are congruent. Okay, so like this angle is across from this congruent side, and this angle is across from this congruent side. Or another way to think about your base angles are they're the angles that are not created by the sides of the congruent triangle, or they're the angles that are created by the sides that aren't congruent, if that makes sense. So like this angle is created by these two congruent sides. Okay, so the angle that's created by the two congruent sides is going to be called something else. Okay, but the ones that do not have two congruent sides are the base angles. Something else we need to talk about are the legs. So the legs of an isosceles triangle are the two congruent sides. So the two congruent sides are called the legs. And finally, the angle that is created by the two congruent sides, then is called the vertex angle. So let's go into more detail on these items. All right, so the legs of the triangle, again, they're the congruent sides of an isosceles triangle. So in this picture, CA and CT are the legs. Are the vertex angle, again, it's the angle that is created by both of the congruent sides. Okay, or you can say the angle formed by the legs, however you want to word it. All right, so in this picture, angle C is going to be the vertex angle. Awesome, right? All right, and lastly, our base angles. So these are the angles that are across from the congruent sides, or if you notice, both sides of the angle are not congruent. Only one of them is one of the congruent sides, if that helps. So vertex angle is made up of both congruent sides. Base angles only has one of the congruent sides. So that might help as you remember. So again, it's the other two angles that have a base as the side as well. So once you know what the base of the triangle is, which the base is the side that's not one of your congruent sides, okay, the base angles have at least one side that is created by the base of your triangle. So in this picture, AT is the base. And in this one, angle A and angle T are the base angles. So segment AT has angle T and angle A kind of connected to it, if that helps you remember. All right, so let's talk about the isosceles triangle theorem. So an isosceles triangle, which we kind of touched on this with the base angles, it has something to do with the base angles of a triangle. So the isosceles triangle theorem states that if the sides of a triangle are congruent, then its base angles are congruent. So in an isosceles triangle, the base angles are always congruent. So if we start with an isosceles triangle, so a triangle with at least two congruent sides, that implies that the base angles are congruent. And remember, those are the angles that are directly across from your congruent sides. So in this picture, angle B is congruent to angle C, as well as side AB and side C, AB and side AC. That should say AC. Ignore that. The demon cat's got me. Sorry, guys. But yeah. All right, now the converse of the isosceles triangle theorem. Converse theorems are the reverse of the original theorem. So the reverse of that, okay, if we know that the base angles of a triangle are congruent, then it must mean that the sides have to also be congruent that are across from them, or the legs. Okay, so again, if we know that in a triangle, the base angles are congruent, That means the sides that are directly across from them will also be congruent. So side AB is congruent to side AC. Okay, so if we go directly across from our congruent base angles, those two sides will be congruent. So yay, that's the isosceles triangle theorem. And we're going to use this theorem to help us solve some nifty problems. So in example 1, 2, and 3, we'll be finding the value of the angle that is listed in each problem. And we're going to be using properties of isosceles triangles and the isosceles triangle theorem to help us solve example 1, 2, and 3. So go ahead and pause the video and watch examples 1, 2, and 3. All right, and that's it for the isosceles triangle piece that we're going to talk about. Aren't isosceles triangles super fun? I agree, you guys. We have so much in common.